Hello Year 5 and 6. This week's investigation is all about bubbles. Why are bubbles usually round, and what can you or can't you control about a bubble? What you're going to do is create some homemade bubble mixture. You're going to need some sugar, some washing up liquid, and some warm water. You're going to experiment with different shapes and sizes of bubbles and see what you can and cannot control about the bubbles. See if you can discover if you can make a bubble that's not round. You're going to need 2 tablespoons of washing up liquid, 3/4 of a cup of warm water, and a tablespoon of sugar. A straw to be able to blow your bubbles, and then various things you can find around the house that you're allowed to blow the bubbles through, like pipe cleaners or paper clips or coat hangers or biscuit cutters. Now, you need to make the bubble mixture. Mix together the sugar, the washing up liquid, and the water. Stir the mixture because this will help to dissolve the sugar into the solution. Apparently, if you make it the night before, the bubble mixture will be better, but you don't have to do that. The most important things to do this week is play and have fun with your bubbles. Look and observe and ask yourself lots and lots of questions. What science can you discover behind and inside and around and about a bubble? The focus this week is prediction. Prediction is the questions you ask yourself of what you think is going to happen before you try an experiment. Remember, if you make a prediction and it doesn't turn out to be correct, that doesn't make the prediction any less valid. Your prediction is what you think might happen, and it's a really important skill for a scientist to have. Try filling in the worksheet to show you've thought about what might happen before you try it. Can you predict what will happen if you blow harder? Can you predict what will happen if you use a square-shaped bubble blower? What happens if you use a heart-shaped biscuit cutter? Does the size of the hole in your bubble blower affect the size of the bubble you get? If you change what goes into your bubble mixture, what happens to the bubbles? Can you find an optimum bubble mixture? Now, get going. Blow, blow, blow. My favourite type of bubble is to do this. Get some bubble mixture on your hand and rub your hands together. Now rub your hand onto a very, very flat surface, maybe a kitchen top. Make sure you ask for permission before you do this. Now you've got some of the bubble mixture on the kitchen surface. You're going to blow a bubble onto that mixture. When you've blown a hemisphere of a bubble, try getting some more mixture onto the very end of your straw, and you're going to blow another one, but this time insert the straw through the first bubble to create a bubble inside a bubble. How many bubbles can you get inside a bubble before they all burst? Have a look at these other examples and try some of those too. Here's some background information. A bubble is a pocket of air surrounded by a very thin film of liquid. Water acts as though it has a stretchy skin. It's this that helps make a round bubble shape. Scientists call this surface tension. The colour of the bubbles is due to the light reflecting off the bubble surface and creating what scientists call interference patterns. The pattern and colour changes according to the direction of the light and the thickness of the bubble skin. I wonder how big you can blow a bubble. The biggest bubble ever blown was 50 feet long and 2 feet in diameter. That's some bubble. Here are some websites you might like to look at. The Royal Institution has a fabulous video of the kind of experiments you might like to do. And the YouTube example is a little more low-key but equally fun of how you can blow a bubble inside a bubble. If you've enjoyed doing this, why not try some other things? Can you make bubbles of different shapes and colours? Maybe use some food colouring. Can you time how long you can keep a bubble before it bursts? Create a chart or a graph and find out how long you can create a bubble before it bursts. Have a look. Do all your bubbles float? Or does some fall to the ground? Does the size of the bubble make a difference to this? Can you catch a bubble without it bursting? And how long can you keep the bubble in the air? Have fun. I'd like you to try doing a little bit of writing up. Fill in the prediction performer before you try blowing bubbles. Record what you observe and try the challenging questions. And then when you've done all of that, apart from having fun, can you take a photo or a little tiny video clip of what you've done and email it to your class email? I'll look forward to seeing them. Bye from Mrs. Cunningham.